You know that feeling when an app just gets you? It recommends the perfect song or finds that one specific image you are looking for. Well, that's not a coincidence. There's some seriously incredible technology working behind the scenes. And today, we're going to pull back the curtain on the engine that makes all of that modern AI search actually possible.
So think about this for a second. You're browsing a shopping app, and out of a literal million different shirts, it shows you the one you love. How does it do that? Is it some kind of mind-reading trick? Well, the real answer is, honestly, way more interesting than that.
Nope, it's not magic. It's something far more impressive. It's a really brilliant combination of some powerful mathematics and just raw, incredible computing power.
See, to make our world searchable for a computer, AI has to do this kind of translation. It takes everything that we understand intuitively, things like images, sounds, text, even the vibe of a t-shirt, and it turns it all into a super detailed numerical description. And these descriptions, these strings of numbers, are called vectors.
And the scale of this challenge, it's just enormous. According to research from IDC, a truly staggering 80% of all the data in the world is going to be unstructured by 2025. We're talking about a tidal wave of images, videos, and text that all need to be translated into these searchable vectors. So that brings us to the core problem, right? Once you've turned the world into a billion of these really complex vectors, how in the world do you find the ones that are most similar to what you're looking for and do it in like milliseconds?
Well, the solution is this really clever trade-off. See, to operate at the speed of the modern internet, you just can't waste time looking for the single, mathematically perfect match. It would take forever. Instead, you have to find something that's good enough, and you have to find it ridiculously fast.
You can think of it like this. An exact search, that's kind of like a turtle. It will check every single item to guarantee you get the perfect result, but it would take an eternity. Approximate search, on the other hand, is the rocket. It uses smart shortcuts to find a whole group of highly relevant results, super fast. It trades just a tiny bit of precision for a massive gain in speed.
And this is where our hero enters the story. This exact problem is what a library from Facebook AI research called Faiss was built to solve. It was a massive breakthrough that made this kind of approximate search practical at an unbelievable scale, specifically by harnessing the power of GPUs.
So how does Faiss get this incredible speed? Well, the secret sauce is a technique called product quantization. Let me walk you through it. First, it takes a really long, complex vector and splits it into smaller, more manageable chunks. Then, for each of those little chunks, it finds the closest match in a pre-computed code book and just assigns it a simple code. And the result? That super long, complicated vector gets compressed into a tiny, easy-to-search code. This compression, this is the genius move. It lets you cram billions of items into a computer's memory and search them almost instantly.
But here's the thing. The algorithm was really only half the story. The real secret weapon was how Faiss was meticulously, masterfully optimized to run on graphics processing units, GPUs, which are just perfect for the kind of massive parallel math needed to search these codes at lightning speed.
And the results? They were just stunning. The research showed Faiss was an incredible 8.5 times faster than the previous best-in-class method. I mean, this wasn't just a small step forward. It was a complete and total game changer for searching at a billion-item scale. To really put that power into perspective, Faiss can build what's called a nearest neighbor graph. It's basically a giant map of how similar every single item is to every other item. It could map out 95 million images in just 35 minutes. And it could connect a billion vectors in under 12 hours with just 4 GPUs. I mean, the scale is just mind-boggling.
But look, having a powerful engine like Faiss isn't really enough on its own. To be truly useful for developers in the real world, you need a whole system built around it. And that's exactly where something like Milvus comes into play. It's a system purpose-built for managing all this vector data. It's really like this. Faiss is the high-performance, screaming fast engine. But you can't drive an engine to the grocery store, right? You need the whole car. You need the chassis, the steering, a system to manage everything, especially new data coming in and old data going out all the time.
And this chart right here, it just lays out the difference perfectly. Sure, both can handle huge amounts of data, and they both use GPUs. But just look at what Milvus adds on top of that. It manages dynamic data, it lets you filter results by things like price, it can scale across tons of machines. These are the absolutely critical features that turn that powerful engine into a car you can actually drive.
So really, what Milvus does is it takes the raw search power of Faiss and wraps it in a robust system that developers can actually build amazing applications with. It's a thing that manages the data, allows for way more complex questions, and makes sure the whole system can grow as an application gets more popular.
So, we've got the engine, Faiss, we've got the car, Milvus. Now for the really fun part. What kind of incredible things can we actually do with this? What does this technology unlock out there in the wild?
This is one of my absolute favorite examples from the Faiss paper. By building that massive map of 95 million images, the system can actually find the smoothest path between two totally different points. In this case, from a red flower to a yellow one, by just hopping between the most visually similar images. It's just a beautiful way to show what it really means to understand similarity at a massive scale.
And the real-world applications are just exploding. Yeah, this is the tech behind your personalized recommendations, for sure. But it's also powering things like drug discovery by searching for similar molecular structures. It's the engine inside intelligent Q&A systems, and it's the foundation for the entire next generation of image and video search. And all of that leaves us with one last, really fascinating thought. We started this whole journey by turning things like images and text into vectors. But if any kind of data can become a vector, we're talking everything from molecules to music styles. What new worlds of information will we be able to search, and what will we discover next?